I think that's the 328 signature, I think.
Yep.
So it read the signature, so now I could actually go and look at the fuses. And so this is a little bit nicer than, you know, I mean, AVR Dude is awesome, but this is a little bit nicer than, you know, having to remember the hex codes to how to set the fuses the way you want. Although if you do have the hex codes, you can just set them right here. But you could, you know, and this is actually, one of these is what I disabled. I might have disabled that on my board.
Sorry.
And I think I disabled the, this flag is what tells the chip that it has a bootloader, so that's what that's what makes it, in Arduino it's got that special bootloader program that runs on boot. That's the flag that tells it, run the bootloader first before the program that's, you know, the main program, and the bootloader will look and see if it's programmed or not, or if it should wait for new code. If you turn that off, and you don't have any means to turn that back on, you will break your Arduino until you could figure out a way to turn it back on. And so that's what I did, and it's not responding to any commands. So I'm not going to do that to Pete's Arduino. And I have never once messed with lock bits. I think that's, I think you can actually lock the code to where I think you can only erase it with high voltage programming, and you can also make it unreadable, so that if you have proprietary stuff, you don't want someone stealing your code, you can make it so that you can't read the code back off of the chip. I've never once actually ever done that, but anyways. So let me, for this, I'm not going to debug it on that. I'm going to do the simulator. And this, I wouldn't even have to have anything plugged in to do that. So I have a breakpoint right here. So I'm just going to start debugging and break. And there it's, and this, if I was running on the actual chip, it would be exactly the same way. It would have a little upload step first, but you could, you know, I could step over it. You know, I could step into it and go, this is the standard, oh no, that's not the standard.
So you can actually single stick the code on the chip?
Oh yeah, with the debug wire and the JTAG. And the Visual Micro that I mentioned, they have a neat thing that's a, they implemented some sort of debug over serial. So you can actually debug without this hardware. You can debug on the Arduino itself. The only thing is that's the only non-free part of it, and I think it's, I don't know, it's like $50 or $75, which is, I don't remember what it was, but it was more than the hardware just to buy, you know, to buy the debugging hardware. But it was still kind of neat. But you can also look at, if I had any variables in this program, you could look at them in this. Here, let's add some variables. Let's just have our program.
You put a watch point in? Can you say stop when A is 53?
I would seriously doubt it. You might be able to do that on ARM chips, but I don't know if you could do that on an AVR.
Set a breakpoint, F9, and then right-click and see if you can set a condition.
Conditions?
Yeah, it doesn't.
A equals 52.
Doesn't like this.
That's sort of different from a watch point.
Yeah.
Oh, you mean like where it actually dumps out the value?
No,
Well-
so what this is doing is it's going to stop regardless and evaluate the condition. But a real watch point would actually be tied into the memory system and would only stop when it hit 53.
I see what you're saying.
And
Sort of
and the
different.
key thing is, for the chips that can support it, it doesn't,
You don't even know where it happened.
it
'Cause
does
it's-
not
'cause it's-
impact your
It
program,
happens
it
when
doesn't
you
change the
overwrite the
timing.
array somewhere
Right.
and stomp on a variable, and so you wanna watch that memory location and see, when it changed.
Find out which SOB changed that,
Right.
Yeah,
that location.
And that's something that I think you need like hardware support
Yeah,
for, that I
yeah.
don't think,
Yeah, no, I just wondered if that would,
Yeah,
if
you,
you
and I
could
haven't,
express it inside that debugger.
that's often, usually when you get to need to one of those, you're in a pretty bad place, you're pretty
You
desperate.
need to switch to ARMS.
You have no hair left because you know,
Which means you need to put in more printfs.
yeah.
which makes the problem go away.
Yeah.
I've done
Then
that.
you're done,
Oh, yeah.
right?
Yeah, the printf creates a Heisenbug.
Yeah.
So if I can put, so A is 42 here, and you can. Oh, the one thing about, I just broke into it, sometimes when you're running the simulator, the delay, you don't realize how many ticks it has to simulate to actually simulate a 1 second delay. It's a whole lot of CPU, it's 16 million CPU ticks of simulating all of its things. So sometimes if I really, if I want to debug and there's I have delays, I'll comment them out, and I usually remember it when I'm sitting there and it's not doing anything or hitting a breakpoint. So you can, or you could just, make it much smaller.
Oh, so a delay 2,000 or 3,000 can take a really long time to
Yeah,
simulate.
yeah, in the simulator it does. When you're debugging, it runs real time, but on the hardware, but in the simulator it can take a while. And you can add, watch, so you can have it down there. And I don't, yeah, this is new. This is in newer versions of Visual Studio. This is a general Visual Studio feature, but you could just pin that. You don't even need this watch window, so then you can run it step.
That's cool.
I know I've kind of running out of time, but I guess that was my, some of this are some of the big reasons, and I'm in the simulator, but a lot of times when I start a new project, I might go 20% into the project before I ever even throw it on actual hardware. So I just start throwing, if I know it's going to be a big piece of code with a lot of stuff going on, I start writing the general framework of it and testing certain things. But and you can examine ports too. So let's see if we can find. I bet that's port.
In 13.
One
That's pin
output.
13. I bet.
Yeah.
Let's see if it. We gotta stop it in between. So yeah, I tell you it changed. It turned on from that one. If we do it again, now it's off. So, but it's sort of limited in as far as you can't do fancy input. It's not. There's no A to C. You can't do it. Analog signals into your simulator to figure out.
There's a stimulus file.
There is. It's very. I've had mixed results. With
You might say it's a mixed signal.
Yes, it's. I think where I really wanted it, where it was to process serial input, and I figured if I just had a capture that was serial data from the thing, and no, it doesn't work like that. So. But on the real one, you could see all this, and you could see all the flags of, if these match the data sheet. If you look in the data sheet, you can see what all these. Actually, it'll tell you what some of these are. The flag that says your is received as complete, or watchdog. I know I have. When you do a raw C++ AVR project, often you you neglect the watchdog until you try to figure out why the things never comes back from reboot.
You
Wow.
can't use the watchdog on an Arduino with a bootloader because the bootloader doesn't kick the dog. And so
That's a good,
so it comes up, and before it gets to your, so I tried to put the kick the dog thing as the first executable instruction. I modified them before
right.
setup. I put them up in main,
right,
and it still doesn't get to it.
right, and that's a good point. So if you did that and you were, say you were debugging and you got in this weird, you'd be able to find, sometimes it takes a little while of trial and error once you realize, but you could look at it and go, oh, I think there's a flag in here, status register that, this watchdog reset flag. So you could look at it and say, oh, that thing is set to true. That means it came back from the watchdog.
Reset, yeah.
So
And it,
with this kind of IDE, you can get to the root of problems that would take you until the end of time
Right, and
with other.
it's
with
not
a
like you
less-
never have to printf, but the equivalent, the equivalent, you were saying that the conditional breakpoint, what, and what I would end up doing usually is, is just temporarily putting something like that in there
And putting a breakpoint.
yeah. And I think there are some this is kind of rough on the chip too, because I think the way that it actually does breakpoints, I think it doesn't have hardware breakpoints, or if it does, it's limited. So it actually inserts code onto the chip to stop it and say break here. And so you can, in the middle of running it, you could be adding and removing breakpoints, and it's doing a mini reflash, I think, every time you do that. So it'll somewhere I've read, Atmel says it's not recommended to use your development chips for
production.
Yeah, that they're ruined because they've been written to so many. I think you can only flash them like 10,000 times supposedly.
Yeah, but for production, you only need one more.
No, that's true. I don't know if it, the life shortened, if it's, because they last X number of years, I don't know if you flashed it 9,999 times, are you still gonna get the full?
Life cycle out of the rest of the thermal cycles.
Yeah, I don't know.
Or they could just want you to buy more chips.
If you don't, I guess Atmel's saying you can't sue us if we told you not to use it.
There's actually a counter in there, just counting the number of reflashes.
I think
That would be a nice feature.
anything else
That would actually.
to cover?
If it was externally readable.
Yeah.
Yeah, oh, yeah.
So one of the things, let's see, it throws all your output in here. This is another Visual Studio thing. And actually, you get these, I think, with Arduino, or you can coax it to give it to you. But one of the neat things is, like this. These are more like GCC things if you ever do stuff with GCC. But you get this map file that has, that one's not as interesting. It might be the LSS. It's going to show you your memory layout of your compiled application, which is pretty cool. So this is your vector table, and I think if you have a bootloader, usually if this first flag or one of these, when there's that bootloader set, it actually goes to one of these and jumps to where the bootloader is. Or it actually remaps, I'm sorry, if that flag is set, it remaps these at runtime to a different different block of flash gets mapped into that spot, so that's how it jumps to the different thing, I think. And all of these are a bad interrupt, I think, is the default GCC if you actually haven't defined these are all predefined interrupts for like your I2C ready or counters and all that. But this has been helpful, and occasionally one of the other things you can do that you can't do with Arduino, and this is getting like really GCC specific, where you can put special attributes on functions to tell it this function belongs to a different block of memory, and see if it has it listed up here. These memory sections. So you can make your own, you can make custom linker scripts, and you can assign functions that belong to a certain section of memory. And it's sort of an arcane use case, but I have run into cases on the 1284 where the, no, it wasn't, it was the Mega. It was a Mega where having an interrupt handler, I think it was a bug, it might have been a bug in something where having an interrupt handler that was above a certain memory boundary, the compiler was, and with optimization turned on, bad things happened and it didn't, and they're like, well, the fix for it, you can force this thing to be in this section or redefine where this section lives. And, and that was actually, for that particular project, was the thing that made me say, I can't do this in Arduino anymore. I have to, because it's flat out not working, and I have to, and I think the way that I figured out it was wrong, just looking at this file.
Right. Is that because the vector uses a short jump?
It might have been, but it's supposed to just handle that, or it's supposed to know it's a short and not try to
Get to an intermediate spot and then
Yeah.
do the long jump from there.
Or just-
and it wasn't doing
or
it.
just tell it, just don't do that,
Right.
It hurts
Yeah.
when I bend my elbow, just don't do
Stop
that.
doing that.
And it's hard with Arduino, with the Arduino build system, you have zero control over any of that stuff, so, with this, you can really, shoot yourself, with all, anything you could put any GCC flag in there to do anything, and there's maybe hundreds of flags.
Yeah.
Or linker flags, or.
But you've got so much flexibility here once you've configured things. There's no returning that result back into the Arduino IDE.
No, yeah, it's sort of a one. If you wanted to go back and forth, do that visual micro thing, so then at least you get some of the, and I didn't do that big project I was going to do, but a lot of the things that are nice is where you can, so it shows, where in the code is that function defined, and then if I was right here, I could go, and hopefully this works, find references, and you can say, oh, that's all the code that uses that function, and when you have a large program like that, that stuff means that,
It's important.
yeah, that you can find it in 5 seconds instead of every time you need to step backwards through the code, it takes you 2 minutes to jump backwards each little step instead of 5 seconds, and it adds up. And I think, I haven't done development in Eclipse for Atmel stuff, but I've done some ARM stuff that has a similar, similar to the way Pete has it. You get your GCC toolchain, and you get things set up, and then you integrate it with Eclipse's C development toolkit, and you get a lot of these same things. So I imagine if the AVR setup on Linux for Eclipse integration, which I think I've heard is out there, nobody would do that if you didn't also get fancy stuff. There'd be no point. There'd be no point in loading this beast of an IDE for you to get the fancy IDE features, I guess is what I was saying. But Eclipse has that too. Eclipse, is a pretty good, is another one of those heavyweight IDEs that has every bell and whistle you could ever want.
I think we're out of time.
Yeah, so, that's kind of it. Sorry, I was sort of a little jumping all over, and I prepared some lame slides and then didn't use half of them, so I just sort of winged it.
I took too long.
Yeah, I think that's,
It's a basic problem.
that's all I have. And-
Thank you.
Okay. Can you try your chip?
Yep.
I could try, I can. It is neat, you can, and this would actually, oh, let me,
No, we have to stop now, John.
okay, oh, we do have.
Yeah, for sure.
All right.
So there were your sand chips.
Yeah. Yeah, so you get JTAG there. If you pick the right one, you get the high, and you have the right settings, you get high voltage.